Thank you for coming to the presentation today. My name is David MESA. My supervisors and co-authors are Christine THONG, Charles RANSCOMBE, and Blair KUYS. I will be speaking about design and science, workshop-based approach for identifying commercial opportunities in universities. And I will be talking about a case study that I'm using for my research. I'm working on a PhD research. And the case study is with a technology that is being developed at Swinburne University, working on a graphene-based technology for energy storage. So the main topic of interest here is trying to identify how to bridge the gap between university research and the market, especially scientific research. So literature has been covered this issue since around 2 decades ago, because it was found that most of the scientific research was not being able to generate a direct impact in the market. So governments and people, because a lot of the researches come from taxes, were saying that what was the purpose of doing all this scientific research if it's not going to impact society? Research is looking at what are the contributions and challenges of integrating the product development process to assist the development and commercialization of early stage technologies from scientific research in universities. So the study is not trying to say that all the scientific research needs to be commercialized, but as the governments every year are cutting the funding for scientific research, but the universities keep growing, then we need to find another way to find to fund our research. So describing the problem, I created this reference model. It's based on the findings from previous literature, and it describes the current situation of technology development and commercialization at universities. So the way this model works is that you read it from the base to the top, and the problems or the factors in the bottom are the roots of the problem that are affecting the market impact. So, for example, if there is low communication with industry, then it means there's going to be a low level of understanding of industry needs, and then therefore there's going to be a low quality of opportunity recognition. So everything in the base that is done poorly, it's going to affect the results. And as there are so many factors influencing technology commercialization, it means it's very challenging to make sure that you're actually doing all the good practices. So this is an influence model that is trying to show what needs to be changed in order to change that situation. It doesn't mean that this research that I'm doing, it's going to explore all these alternatives, but this model helps trying to understand the field a little bit. Specifically, we will be looking at how to increase the understanding of industry needs and how to improve the entrepreneurial approach that will be taken. And the research actually ended up looking at technology demonstrators as well and how they can impact technology commercialization. So research already has identified benefits that designers can bring to scientific research, but we needed a clear framework or a clear structure on how to collaborate or how to do collaborations between the two disciplines aiming to commercialize technologies. And it's important to highlight that these are TRL, are technology readiness levels. They were developed by NASA to evaluate projects, and basically when they are at immature stage, this is fundamental science where there are no clear applications yet. And in a technology readiness level 4, there are already some applications identified, but the technology has only been tested in the lab. So what I'm trying to show here is that design plays a very important role, and here I'm speaking about like the design domain, design and the methodology of design and the tools we use, because design inquiry is trying to take knowledge and transform that knowledge into material products, or they don't need to be material, they can be services. But in the case of technologies, it should be our responsibility to try to identify or try to take that knowledge generated by the scientists and try to find applications or market needs to see how we can transform that knowledge into products. So the argument here is that this shouldn't be only science responsibility or the responsibility of scientists, because we cannot ask them to be good at research and also to be experts in marketing and to be experts in product development and engineering. So there are other disciplines involved in this process, and there should be other disciplines involved, but I will be focusing on science and design mainly. So this is the framework that was developed. It integrates the product development process from Eppinger and Ulrich. And I also added some stages based on technology management literature. So this on the left is showing the phases of technology development. And we can see the value of that here as well, and what are the activities that should be conducted in terms of product development. This is the methodology that I used. I'm not going to go in detail into it, but basically I conducted observations and preliminary interviews to create the reference model. And after analyzing it, the impact model was created. Then the framework for the collaboration, and that framework was tested using practice-based design research. And then I conducted final interviews to the scientists that collaborated with me. And I did a survey to people outside the study to see what were the perspectives of people that were not biased. The observations were done at group meetings, group activities, experiments, and conferences for more than 2 years that I was working as another team member in the scientific research group. The interviews I did cover a different range of disciplines and level of expertise and level of experience in research. I wanted to get different opinions and different views on technology development. I'm not going to go into too much detail into the results because I want to spend some more time speaking about the workshop, which was the main topic in the paper. But it was interesting here to see that all scientists want to generate society impact in the society, but most of them, 7 of 8, actually said that they want to stay in academia. And some of them say see technology commercialization as a path that is not very attractive because they relate it with living the academic environment. I also was looking for what are the challenges, are the good practices or enablers for technology commercialization. I got very good information. There was one professor that had a lot of experience in technology commercialization, so it was very insightful. And I identified some barriers that were not mentioned by literature. So this is a stage of the research data collection, allowing me to get more understanding of the scientific research field and how technologies are commercialized and developed in universities. For the practice-based design research, when I started implementing the framework, I started by defining a strategy for the collaboration and for the development of the technology. For this, I worked with the head scientist of the group, and we explored what was the current state of the research from the technical side, like what we can do today. Then we analyzed existing commercial agreements, because we had an industry partner and we didn't want to develop something that would have legal issues with them. Then we identified some possibilities or routes to market, depending on the entrepreneurial approach we selected. Would be interested in doing licensing, for example, or we want to use the IP to create a new company. And then after we understood that, we identified some initial opportunities by looking at what were the strengths and limitations of the technology we had. And the group, this is important because we also need to look what we have in terms of resources and knowledge. So after that, we set an overall strategy for the technology development. And this is where I want to put more interest in, because this is how we selected a market or different markets for developing the technology. So The first stage was identifying market, user, and technology trends. This is very important because when we're designing a technology or we're going to develop a technology, we cannot try to analyze the problems of the society right now, but we need to try to understand the problems of the society of the future, because the technology is going to take sometimes 5 or 10 years in order to be ready to reach market. So we need to try to generate something disruptive for the people in the future. Otherwise, then we would develop or spend a lot of resources on a need that may not be a need in the next 5 years. Then after we identified those scenarios, we did opportunity identification workshop. So in the workshop, we use 4 different scenarios, and we ideated around them, like what are the market opportunities, what are the market sectors around these problems. For the market, user, and technology trends, it's important to say that they're usually available because governments use them for generating policies for the future and for the next upcoming years. So it's a good guide that can be used in this context. And then technology road mapping was applied as a tool to select the best opportunities. And we can see here a snapshot the workshop when we were working on it. I was working as an observer. I didn't participate because I didn't want to intervene. And at the end, all the information was compiled. In here, there are only 3, but it was compiled in 4 opportunity maps. And look at the amount of market sectors that we identify where our technology could have an impact. We use technology road mapping for selecting applications, and this is a very good tool because it allows to identify what are the market needs. Then we already know what our technology can do, and then we know what are the resources we have, and now we know some applications we can develop. So it was very important to be able to align all this. And this is an example of a roadmap. So it let us understand what we can develop in the near future, what actually we can develop after that, and then what is the vision for the technology. This is our final goal. But developing technologies, it's important to understand that we cannot reach it without going through different phases first. And this is a little bit of how the applications look like. Then we did some selection process when we had some market criteria and some technical criteria. So we compare all the applications, we compile the results together, and we ended up identifying and developing prototypes for 2 of them. After the prototypes, we actually ended up doing 2 demonstrators and presenting them in a conference. But if we can see here, more than 100 market sectors were identified, 40 technology applications, 4 technology roadmaps were created, 16 applications were evaluated, and we identified 2 new opportunities for doing new research projects and 2 products for development. This research will facilitate the development of technologies in universities. It aims to show the challenges of the current academic system in terms of incentives and how it measures the academics, and it hinders technology development. We want to show scientists the alternatives they want for developing market-focused applications. And hopefully we will be able to increase research impact and to do a more responsible technology development by understanding those implications that we would be able, or that we would have in the future when we develop technologies. Thank you so much. Thank you for your time.